So, what is weak acid and weak base? Weak acid. Acid that only partially donates proton, H+, in aqueous solution. This means it does not give all its hydrogen ions into the water. Weak acids typically have a pH between 3 and 6. Example, acetic acid and oxalic acid.
Weak base. Basic substances that do not completely dissociate into their constituent ions when dissolved in solutions. Weak bases release hydroxide ions. Example, aluminum hydroxidioned lead hydroxide.
Are these important in cellular processes?
Yes, it does. Weak acid and base play important roles in intracellular pH regulation, because our cell and enzymes works the best at pH 7. What is their role in intracellular pH regulation? Weak acid and its conjugate base and weak base and its conjugate acid will act as a buffer. Buffers will stop pH from rising or falling too quickly besides maintain it in normal range. The reason the body needs buffers is that acid or molecules that readily give up their hydrogen ion are being generated by the body all the time. These extra hydrogen ions would shift the pH into the acidic zone, so the body needs a way to handle them without a major shift in the overall pH. To accomplish this, buffers can essentially take on some of these extra hydrogen ions and therefore keep the pH from dropping too much. So when the intracellular environment becomes too basic, weak acids can release hydrogen ions to lower the pH back to a normal range. So the intracellular activity can be done efficiently. When the environment becomes too acidic, weak bases release hydroxide ions, OH, that can bind to excess H ions, helping to neutralize the acidity and raise the pH. What do you think the other molecules that is involved in this reaction?
Let me guess. I think hydronium ions and hydroxyl ions.
Yes, that's right, and their function is. Hydronium ions will represent the acidic nature of a solution, formed when an acid donates a proton to water, while for hydroxide ions it will represent the basic nature of a solution and formed when a base accepts a proton or dissociates in water.
What are the structure of weak acid that influence their role?
Weak acids, like acetic acid, have a carboxyl group, COOH, which can donate H ions under certain conditions. The structure of this functional group makes it capable of partial dissociation in water, contributing to its role as a buffer.
But why this happened?
Many of the acids important in the cell, such as molecules containing a carboxyl, COOH, group, are weak acids. And its tendency to give up a proton with some reluctance is exploited in a variety of cellular reactions. Protons can be passed readily to many types of molecules in cells, thus altering the molecule's characters. The hydrogen ion concentration inside a cell, its pH must be closely controlled. Acids will give up their protons more readily if the hydrogen ion concentration is low and will hold on to their protons when the hydrogen ion concentration is high.
What are the structure of weak base that influence their role?
Weak bases, like ammonia, have an amine group that can accept H ions. This makes them less dissociated than strong bases, but able to neutralize acids in the environment. Weak base has limited tendency to accept a proton from water. Weak base also contain an amine group, which can generate hydroxide ion by taking a proton from water.
Hydroxide ion combines with a proton to form a water molecule. An increase in the hydroxide ion concentration forces a decrease in the hydrogen ion concentration.
But what are a reversible reaction?
A reversible reaction is a chemical reaction in which the reactants can form products, and the products can also react to form the original reactants.
Do you know that a substance can act as a buffer?
Amino acids have both acidic, carboxyl, and basic amine groups, allowing them to act as buffers in proteins. Their side chains, R groups, influence their ability to accept or donate protons, thus contributing to pH stability within the cell.